Here we're going to be using trig ratios to find unknown sides or angles. Sorry for that pause. Here we're looking for this angle. Oh boy, looking for this angle. There we go. We know the hypotenuse and the opposite. So I'm going to use sine for this one since it has to do with the opposite and hypotenuse. So I know sine x equals opposite over hypotenuse. Since I'm looking for the angle, I'm going to use the inverse of the sine. So I know x equals sine inverse of 7 over 10. Over here to my calculator. Remember to always check your in degrees. And now we're going to go ahead and hit sine inverse. It's functions. Sine with a -1. Using another calculator, you might see arc sine means the same thing. 7 over 10. And that's 44.42. Nearest tenth, so we know that x equals 44.4. Throw degrees on there, so we got it. 10. We know the angle. This time we know the opposite, and we're looking for the hypotenuse. So here's the angle. That's our focus. Opposite and hypotenuse. Opposite and hypotenuse again is sine. So I'm going to go sine 52 equals the opposite 10 over the hypotenuse x. If I multiply x to get it out of the denominator, I end up with x sine 52, so I'm going to divide by that sine 52 to get x by itself. So 10 divided by sine 52. I like to write out those equations every time. I know I can probably feel comfortable doing most of this in your head, but I think it's just a little bit cleaner to make sure you're writing it out so you're solving it the right way. Also, when I'm grading, it lets me see exactly what you did. Sine 52. And we end up with 12.69, rounded to the nearest tenth. X equals 12.7. In number 11, we look for our focus right here. That's the one that we don't know. We've got our opposite and our adjacent. That tells me tangent. So I'm going to go with tan x equals that opposite 21 over the adjacent 15. Again, I'm going to go with the inverse here. So x is going to equal tan inverse of 21 over 15. And we're going to go tan inverse 21 over 15. 54.46 and 54.5 degrees. In number 12, we've got our right angle, we've got our angle that we're focusing on right there. This is our adjacent, this is our hypotenuse, so that's cosine. So I know cosine 37 is equal to adjacent over the hypotenuse x. Again, when x is in the denominator, we multiply, divide, so we end up with x equals 9 divided by cosine 37. 9 divided by cosine 37, functions cosine 37. 11.26 or 11.3. Number 13, we're looking for a side. We've got our focus angle right there. The side is opposite and hypotenuse. Opposite and hypotenuse is sine. So we're going to go sine of 55 equals that x over 7. I can multiply both sides by 7. So x is going to equal 7 times sine 55. Sorry, I'm instructing this, getting a little cramped here, but we'll work with it. So 7 times sine 55 is 5.73, rounded to the nearest tenth. 5.7 equals x. You do want to make sure that your answers are making sense. Look at it, make sure your hypotenuse is your longest side, and kind of make sure those lengths kind of make sense within the context of the problem. Next up, we got our focus angle right here. It's 50 degrees. Opposite, adjacent. That tells me it is tangent. So I know tangent of 50 is equal to opposite over adjacent. Multiply by x, divide by tan 50. 4 divided by tan 50. Go over here, 4 divided by tan 50. 3.35, rounded to the nearest tenth. X equals 3.4. Also, one note while we're talking about this, the more work you show, the more lenient I can be with your rounding. If you're not rounding to the right decimal place, you're off by a little bit. If I can see your work, I can see that you understand what you're doing or that you don't, and that lets me decide what to do with that. All right, focusing on 31, we've got our opposite and our hypotenuse. Since the opposite and hypotenuse, sine of 31 equals 12 over x, multiply by x, divide by sine 31, x equals 12 divided by sine 31. We want to make sure that we are not rounding too soon. Oh man. There we go. All right, so 12 divided by sine 31. 23.29, 23.3. Pretty good answer there. Number 16. Got our angle, got our adjacent, and got our hypotenuse. So COTA, cosine 40 equals adjacent over hypotenuse. Multiply both sides by 24. And that gets our x isolated. So we're going to go 24 times cosine 40. Yep, 40. 18.38 or 18.4. All right, and 2 left. Oh, plenty of room for these two. All right. Number 17 is kind of special. I know all 3 sides, so I get to pick and choose which one I use. It does not matter which of these trig functions you use. They will all work. They all get us to the right answer, but we're going to focus on x. For me, I'm just going to go with opposite and hypotenuse. That's going to give me a sine. So sine x equals opposite over hypotenuse. Since I'm trying to find the angle, I'm going to use the inverse. 5 over 13. And move it over here. We're going to go sine inverse of 5 over 13. And that's 22. Just really quick, 22.619. If I used cosine, then I would have had cosine inverse of adjacent over hypotenuse. So that's 12 over 13, 22.619. And if I'd use tangent, I'd have tangent inverse of opposite over adjacent, so that's 5 over 12. All 3 give me 22.619. So x equals 22.6. And here, number 18. Since I'm given 2 of the sides, I'm going to use those 2 sides. Unlike number 17, where we had unlimited choices, 3 choices. 6 choices we could use, so secant, cosecant, or cotangent. We've got our angle, hypotenuse, adjacent. I'm going to use cosine for this one. So we've got cosine of x equals adjacent over hypotenuse, or 1/2. This might start speaking to you pretty quick. This is that 1/2 ratio. Hopefully you look at this one and you're like, that might be 60 because it's a 30, 60, 90 triangle. You'd be right. But just because we got our calculator open, we're good here. We're gonna go cosine inverse. I need to write this down. Cosine inverse of 5/10, or 1/2, and we do get 60. So what I did here, cosine inverse of 5/10. And that's what got me my 60 degrees.